Stephen Schwartz, a personal injury lawyer in New York, found himself in deep trouble in the spring of 2023. Tasked with arguing a complex case, he turned to ChatGPT to draft legal briefs. The AI confidently provided a series of precedents, citing previous court rulings and case numbers. Schwartz copied them directly into his filing. It seemed like a clever shortcut. But when the opposing counsel couldn't find any record of these cases, and the judge demanded an explanation, Schwartz had to admit the truth. The AI had simply invented them. Every single one was a complete fabrication. The names, the dates, the rulings, all fake. This wasn't just a minor mistake, it was a professional disaster. The AI didn't just get a fact wrong, it confidently manufactured entirely new facts, complete with specific, plausible-sounding details. It's a phenomenon now widely known as hallucination, where large language models like ChatGPT, Google's Bard, or Microsoft's Copilot invent information that isn't true, but sounds incredibly convincing. This leaves us with a critical question. Why do these powerful systems, trained on vast amounts of data, just make things up? And more importantly, if they can do this, can we ever truly fix it? Many assume it's a bug, a flaw that can be patched with more data or better programming. But I dug through the numbers, the models, and the math, and what I found suggests it's something far more fundamental. The reason AI models invent fake facts, and why we can't fully fix it, comes down to three hidden principles of their design. Most of us interact with AI models as if they are superpowered search engines, or perhaps a digital assistant with a perfect memory. We ask a question, and we expect it to retrieve a fact from a vast internal database. We imagine it sifting through trillions of pages of information, finding the correct answer, and then presenting it to us. But this is where our fundamental misunderstanding begins. That's not how they work at all. An AI model doesn't know facts in the way a human does, nor does it search a database. Instead, it's a highly sophisticated prediction machine. Its entire operation is based on calculating the most statistically probable next word, or token, in a sequence. Think of it like the autocomplete function on your phone, but on an unimaginable scale. When you type "How are you?" your phone predicts you because that's the most common and statistically likely word to follow. An AI model does the same thing, but across entire paragraphs, essays, or even book chapters. So the first reason these AIs hallucinate is that they are prediction engines, not retrieval systems. When you ask ChatGPT about the Castle Gold apartments in South Korea, it's not looking up details in an index. It's taking your question, breaking it down into a sequence of tokens, and then calculating the probability of every single possible next token in its vocabulary. It then selects the one with the highest probability, adds it to the sequence, and repeats the process, generating word after word until it decides it's finished. Its knowledge is embedded in the statistical relationships between billions of words and phrases it learned during its training. It simply predicts what sounds like a good answer, not necessarily what is a factual one. This probabilistic nature leads to a fascinating and often frustrating problem, the illusion of truth. If an AI is merely predicting what sounds likely, how can it produce entire, coherent narratives that are completely fabricated, like the fake court cases from Stephen Schwartz? The answer lies in the subtle difference between statistical plausibility and factual accuracy. Human language is rich with patterns, structures, and stylistic conventions that often signal truth, even if the content itself is false. For example, a legal citation follows a specific format: a case name, a volume number, a reporter abbreviation, a page number, a court, and a year. An AI model, trained on billions of legal documents, learns these patterns perfectly. It understands that Smith v. Jones, 123 F3D 456, second sir, 2022, looks like a valid citation. The statistical probability of that sequence of words and numbers appearing in that format is very high in a legal context. So the second reason for hallucination is that these models generate text based on statistical plausibility, not factual validation. When an LLM generates a response, it's essentially navigating a vast, multidimensional semantic space. Every word or concept exists as a numerical vector, and similar words are clustered together. When the model tries to predict the next word, it's essentially finding the most probable path through this space. If a user asks a question that nudges the model into a region of this semantic space where a statistically plausible, but ultimately false, statement has a very high probability, the model will confidently generate it. It doesn't have a mechanism to say, wait, this sounds right, but is it actually real? It just follows the highest probability path available in its learned patterns. It's like a highly skilled mimic who can perfectly replicate the sound of a language, but doesn't understand the meaning of the words. You might wonder, why can't we simply build a fact-checking module into these models? Why can't the AI, after generating a statement, run a quick search to verify its claims before presenting them? This leads to the third and perhaps most challenging aspect of AI hallucination, the inherent lack of an independent truth mechanism. An LLM does not possess a separate, fact database that it can query to confirm its own generated output. Its entire knowledge is the statistical patterns derived from its training data. When it generates text, it's not drawing from a separate store of verified facts. It's simply applying the learned probabilities. It has no internal concept of true versus false in a factual sense, only statistically likely versus statistically unlikely. This means that an AI model operates without an independent ground truth. Imagine you're writing a novel. You invent characters, plot points, and dialogue. You don't, in the middle of writing, pause to check if your fictional characters actually exist in the real world. Your goal is to create a plausible, internally consistent narrative. An LLM works in a similar way. Its objective is to generate text that is coherent, grammatically correct, and contextually relevant to the prompt, based on the statistical relationships it has learned. It's not designed to be a truth teller, but a fluent language generator. Even if you connect an LLM to the internet and tell it to search for information, the generation process itself is still fundamentally probabilistic. The search results simply become additional context that the model uses to predict the next token, not a separate arbiter of truth. This is why even advanced systems like Google's Bard, which has direct access to web search, can still confidently invent facts, like when it recently claimed the James Webb Space Telescope took the very first pictures of exoplanets, which it did not. So if hallucination is baked into the very nature of these probabilistic models, does that mean we're stuck with it? Is it truly unfixable? The challenging answer is that, in a fundamental sense, yes. Complete elimination of hallucination would require transforming the LLM into something it isn't designed to be. The creativity, flexibility, and ability of these models to generate novel and surprising text, qualities that often make them so useful and impressive, stem directly from their probabilistic, predictive nature. They can combine concepts and words in ways they haven't seen before, leading to new insights or imaginative stories. But this very same mechanism allows them to combine words in ways that are factually incorrect, yet statistically plausible. Trying to completely stamp out hallucination would be akin to asking a poet to only produce statements that are strictly verifiable facts. The moment you constrain the model too tightly, forcing it to retrieve facts rather than predict fluent language, you lose the large language model aspect that makes it so powerful. Hallucination is an emergent property of the statistical generation process itself. It's not a bug that can be patched with an if-then statement. Researchers are constantly working on techniques like reinforcement learning from human feedback, or RLHF, which involves human trainers flagging incorrect outputs. This helps to reduce hallucinations by teaching the model to avoid certain high-probability paths that lead to false information. But it doesn't change the underlying engine. It's like teaching a child not to lie. You're shaping their behavior, but not altering their fundamental capacity for imagination. There's also the temperature parameter in LLMs. A higher temperature makes the model more creative and less constrained, increasing the likelihood of hallucination. A lower temperature makes it more conservative, sticking closer to the most probable sequences, which reduces hallucination but can also make the output bland and less insightful. It's a trade-off. The implications of this fundamental design are significant. Companies like Microsoft are pouring billions of dollars into integrating these AI models into their core products. If the underlying model can confidently invent fake facts, what does that mean for critical business decisions, legal advice, or even medical diagnoses that might rely on these summaries? This isn't a theoretical concern. In early 2024, a major tech company revealed that its AI chatbot, designed to assist in customer service, had a tendency to provide incorrect information, leading to customer frustration and reputational damage. The problem wasn't a lack of training data, but the inherent probabilistic nature of the model trying to generate helpful responses under pressure. The cost of these errors can be immense, from wasted time and resources to significant legal and financial liability. The challenge is that while humans can understand concepts, reason, and verify information against a model of the real world, an LLM only sees a vast network of statistical relationships between words. It doesn't know what a president is or what democracy means in a conceptual sense. It only knows which words are likely to appear near president or democracy based on the patterns in its training data. This means that even with sophisticated guardrails, an LLM will occasionally produce fluent, convincing, and utterly false statements because those statements simply represent a high-probability path through its semantic space. The push for AI adoption often focuses on its impressive capabilities, its speed, and its ability to generate creative content. But the inherent tendency to hallucinate remains a persistent shadow. It means that while these models can be incredibly powerful tools for augmenting human creativity and productivity, they cannot, and perhaps never will, be trusted as ultimate arbiters of truth. We must always remember that what they generate is a statistically plausible string of words, not necessarily a reflection of reality. The burden of fact-checking still rests firmly with the human user, who must act as the ultimate truth filter. Ultimately, the core issue is that these systems are designed to generate language that sounds correct, not to understand or represent truth. This means that as long as we use them as language generators, the possibility of them inventing fake facts will always be present, an unavoidable byproduct of their statistical brilliance. Its confidence is a statistical calculation, not a measure of its belief in truth. Subscribe to Loopback, and the next video is waiting for you on screen right now.